Hi, everybody. Having worked through that example with mopeds and position with this complicating factor of helmet use, let's talk about what a confounding factor is in general. And I should say that many of these slides are modified from the textbook resources, including this one. So what is a confounding all about? It's when we have this kind of mixing or muddling up where there's an exposure we're interested in and an outcome we're interested in, but there's something else that's an important part of the story, and where part of the apparent effect is not due to the exposure that we care about, but rather due to this something else. And that happens when the exposed group and the unexposed group are different in other ways. They're not different just because of the exposure, but there are other things that go with that, like the fact that the drivers of mopeds were a lot more likely to be wearing helmets than the passengers were. So that's this idea of confounding. There's an example a lot of people like to use, which is, do yellow fingers cause lung cancer? If you look at people whose fingers are yellow, you'll see higher rates of lung cancer than among people whose fingers aren't, because smoking is disgusting, guys. Smoking can literally cause your fingers to yellow, as well as, of course, causing lung cancer. So smoking would be the confounding factor, the hidden factor that explained this apparent association. So let's quickly run through one more example. Let's say we're looking at whether coffee drinking causes coronary heart disease. By looking at a case control study of coronary heart disease, we have our cases, very simple here, 20 people with heart disease. Our controls, 20 people of the same age and gender makeup who don't have heart disease. And we have our question. So first we'd sort them out into the exposed and the unexposed, where the blue cases here are people who drink coffee regularly. So we have 10 cases who drink coffee. We have 5 controls who drink coffee. And if you calculate the odds ratio, you get an odds ratio of 3. I'm going to call this the crude odds ratio because it isn't taking any confounding factors into account. It's just a simple calculation. Okay, let's add in a confounding factor, just like we did for mopeds. Let's think about smoking. Now, we know that smoking causes coronary heart disease, so it is definitely associated with the outcome. And it might well be that it's also associated with the exposure, that smokers might drink more coffee than non-smokers. So if that were the case, then it really would muddle up our picture. So let's split our group, stratify them by smoking status into the smokers and the non-smokers. And then among the smokers, we have a bunch of coffee drinkers and only a few non-coffee drinkers. Among the controls, who are smokers, again, we have our coffee drinkers and our non-coffee drinkers. And then in this case, it really looks like the non-smokers had very different coffee drinking rates. So I want you to calculate the odds ratio separately for the smokers and for the non-smokers and record your results on the class form, as well as whatever conclusions you can draw. Okay, welcome back. When I did this, I got an odds ratio for the smokers of 1 and an odds ratios for the non-smokers also of 1. So with that calculation, what can you conclude about the association between coffee drinking and coronary heart disease? Remembering that coffee drinking was our basic exposure here. Again, go back to the class form and answer. Okay. What I would say is that after we adjusted for smoking, then we saw no association at all between coffee drinking and coronary heart disease. So there was this really large odds ratio, but it was completely confounded by smoking. Smoking is strongly associated with exposure and with outcome. And this really large change in the odds ratio makes it clear that confounding was a huge issue for this study. A picture we like to draw looks like this. We have our exposure coffee and this arrow, this so-called causal arrow. We want to know if coffee leads to coronary heart disease, but D, that's my disease or my outcome. I have this confounder C of tobacco smoking, which is associated with both the exposure and the outcome. You're probably going to hear me say that a lot. That's a really important piece, and that makes it very hard to interpret this story. So what makes something a confounder? Kind of repeating what I just said. A confounder has to be associated with the outcome among the unexposed people. So when you look at the people who didn't have head injuries, among the unexposed. When you looked at, never mind, I just confused myself there. When you looked at the drivers, then helmet wearing was associated with head injury rates. Similarly, it has to be associated with the exposure. We saw that drivers were a lot more likely to be wearing helmets than non-drivers and passengers, or that coffee drinkers, smokers were a lot more likely to drink coffee than non-smokers. And it can't lie on the causal pathway between the exposure and the outcome. It can't be an intermediary. So for the rest of this video, I just want to explain what that means. Again, let's look at an example. Let's say we're looking at an association between income, either low or high, and let's run with heart disease. Okay, so that's a reasonable question. Is it associated with heart disease? And in that case, one important confounding factor, or one important thing to look at, might be fruit and vegetable consumption. And that should be related. We know that a diet high in fruits and vegetables is associated with lower rates of heart disease. And it seems very plausible that income is associated with levels of fruit and vegetable consumption. So does it make sense to call this a confounding factor? Give me any thoughts you have about this on the form. Okay, let's think about this. It's a little funny because it's not just that fruit and vegetable consumption has something to do with income. It's that being low income can directly lead to it being harder to buy fruits and eat fruits and vegetables. There's issues with food deserts. Low income areas often don't have as many good local sources of quality food. Also, fruits and vegetables are essentially more expensive per calorie. So if you're concerned about the cost of your food, you may not buy them. They also take prep time and work. So there are lots of reasons why income could lead directly to lower fruit and vegetable consumption. And we believe that then leads to heart disease, which means we shouldn't be thinking of this just as some independent third factor. It really makes sense to draw a picture like this. Income leads to fruit and vegetable consumption being low, which in turn leads to heart disease. It's part of why this association exists. That means we really shouldn't be calling this thing a confounding factor. It's an important explainer or part of the story. Now, it's not the only one. A more complete picture might look something like this, where we have income leading to lower fruit and vegetable consumption, leading to heart disease. We also might have low income leading to less access to healthcare, which could lead to heart disease. There's a lot of pieces to the story, but in a case like this, it's really not reasonable to call fruit and vegetable consumption a confounding factor. This is the sort of thing that we would call part of the causal pathway. Okay, that's the end of this video. I'll start on the next one pretty much right where we left off.